Hey everybody, so please welcome back on my YouTube channel, and in this particular session we are going to continue with the same method again with the Milne's theorem, which was actual remaining in our previous sessions. And as I said previously that there are remaining now 3 or 4 examples. So today in these sessions we are going to complete that those all examples. So let's start with today's session. Okay guys, so here it's given 14th example, and in this session we have completed 13 examples, and previously I have given one example for the practice, and I hope you all did it very well because nobody yet contact me to solve the examples. So hope you all understood very well. Nice, very well guys. And now here it's given 14th example, and the question is given: determine the analytic function f of z u plus iv. It means again here you are going to find f of v, yani ki analytic function only, if 3u plus 2v equals to y square minus x square plus 16xy. So as I have said here, this a particular equation will function will maybe change, right? Because in 12th and 13th example, yani ki in our previous sessions, it was given like a u minus v form, and here you can observe here it's given u 3u plus 2v form. Okay, so definitely little bit steps will be also changed. Okay, so first of all starting with the f of u only, so f of u yani ki u plus iv, and now next again multiplying it with by I only, so I f of z equals to iv minus v. Okay, now we have applied adding equation number 1 and 2. Okay, but here you can see that this particular function is changed. Barabar, it's not same like the u minus v. Here it's given 3u plus 2v, so definitely it will be changed because वहाँ पे जो हम मेथड कर रहे हैं वहाँ पे आपको functions कौन से मिल रहे हैं, u minus v and u plus v, and here you can observe that here it's not given from this both functions, no, whether it's u minus v or whether it's not given u plus v. Okay, so definitely this we will not add the functions, yani ki we will not take addition of the first and the second equation. Okay, so for that here I'm multiplying with equation 1 by 2 and equation 2 by 3. तो इक्वेशन फर्स्ट को हम लोग मल्टीप्लाई कर रहे हैं 2 से, एंड सेकेंड इक्वेशन को हम लोग मल्टीप्लाई कर रहे हैं 3 से. ओके, एंड देन आफ्टर एडिंग दिस बोथ दी टर्म, so इक्वेशन 1 मल्टीप्लाइंग दी 2, सो फर्स्ट को हम लोग कर रहे हैं मल्टीप्लाई इक्वेशन 1 मल्टीप्लाई बाय 2, so doing with multiply by 2, so it will be 2f of z, and this one again multiply by equation 2 with multiply by 3. ओके, सो इसको 3 के साथ मल्टीप्लाई करके दोनों का एडिशन ले रहे हैं. सो यहाँ पे होगा 3if of z इक्वल्स टू this one multiply by 2, so 2 into the u plus iv, and this one multiply by 3, so 3 into the this function. so यहाँ से 2 से मल्टीप्लाई किया है और यहाँ से मैंने किया है 3 के साथ. then after giving the simplification and separate the terms into the real as well as into the imaginary part. So you will get 2u minus 3v and 3u plus 2v, and here you can see that 3u plus 2v, it's already given into the equation. You can observe guys, right? और यहाँ पे भी हमें मिल रहा है 3u plus 2v. So now you have to just apply capital U and capital V as a supposition. So, and here from this both the functions, f of z will be the constant, so I am taking outside. So 2 plus 3i into the f of z equals to, now here also I am applying supposition, so capital U plus I capital V. So this is term this term is given from the imaginary part, not from the real part. So this equals to, I am taking capital F of z, this is this capital U yani ki 2u minus 3v, and this capital V equals to 3u plus 2v. So here I have written this all the components, that f of u equals to this, u equals to this, and capital V equals to this one. Okay, so now with the same procedure as we were doing, the all the 4 steps you have to apply now. And here you can observe that the given function is coming into the imaginary part. So here you have to apply capital V equals to the given form. So capital V equals to will apply 3u plus 2v. And what is 3u plus 2v? It's nothing but y square minus x square plus 16xy. And here we are finding of imaginary parts. So you have to apply the second case, right? So for the second case, you need to find v with respect to x and v with respect to y, and then after f dash z we will apply. And here you can observe that f dash of z equals to del u by del x plus I del v by del x. And then after you have to apply its CR equations. So here it will be change, and then after putting these both the values and separate real and imaginary part, and then after putting the values of x and y, yani ki z and 0 in place of x and the y. So you will get this one term 16 minus 2y into the f of z, sorry, into the z. And then after the last into the fourth step, you have to integrate the terms, right? So taking integrations on both these sides, you will get capital F of z equals to 16 minus 2y keeping as it is, and the integration of z will be z square by 2. So यहाँ पे मैंने लिखा है z square by 2 plus c as a constant. Now you can observe that these two will be cancelled out from the numerator. So the remaining term will be 8 minus I into the z square c. So this one we have found analytic function, but this one is coming into the capital F of z form. It's not coming its normal form. So now we will convert it into the normal form, yani ki without the supposition which was given into the equations. Okay, yani ki normal F of z and normal u and v form. Okay, so converting that, f of z equals to you will get yani ki applying this 2 plus 3i into the f of z, this we have value यानी कि 2 प्लस 3i f of z, जो हमारी नॉर्मल, जो हम लोगों ने वो प्रीवियस स्लाइड्स में लिखा था, वो उसकी नॉर्मल वैल्यू कैपिटल f of z की वो मैंने यहाँ पे लिखी है. बाकी सब टर्म्स आपकी एज इट इज. ठीक है. नाउ 2 प्लस 3i कन्वर्टिंग मूविंग इनटू द डाउनस्टेज. So then after I'm multiplying its conjugates to remove the I from the denominator. So to remove the I from denominator, I'm multiplying with its conjugate. Okay, and this one I'm taking C dash. So the remaining term will be, at the last term you will get f of z, yani कि analytic function will be 1 minus 2i into the z square plus C dash, where C dash is equals to C upon 2 plus 3i. So this one was little bit different, the term was little bit different guys, but the rest of the method was as it is. So hope you all understood very nicely guys. Now one more example, and the question is given, show that the function u of x comma y equals to e raised to x cos y is harmonic. So in the very first component you have to show the given function is harmonic, and to show the harmonic, you know very well, you have to show ux6 plus uyy equals to 0. Now next one is given, determine its harmonic conjugate and harmonic conjugate v. So यहाँ पे ऑलरेडी आपको बोल दिया है कि हार्मोनिक कॉन्जुगेट फाइंड करना है, एंड वो भी किसके फॉर्म में, v के फॉर्म में. And the analytic function f of z equals to u plus iv. So here again you are going to find three components. First one harmonic, then after analytic function, and then after we will find the harmonic conjugate. Okay, so this is again of the same method, guys, and so that's why I'll just give highlights of the example. First of all, the part of the harmonic, यानी कि you have to find ux6 uyy. So यहाँ पे मैंने find किया है, guys, and this one is coming 0, so based on that we can write the given function is harmonic. Now to find the analytic functions, you have to apply those 4 steps, and those 4 steps of real or imaginary, that will be depends on the equation. The equation is given into the real parts, so definitely it will be we will apply for the case 1 only. Okay, so f dash z equals to del u by del x plus I del v by del x, and in this equation we will use its CR equations also, so this one will be like this way. And then after third step, x equals to z, y equals to 0. So that's why it will be, find the function a so that u of x comma y equals to ax square minus y square plus xy is harmonic. So here already it has been told the given function is harmonic. So for that you have to find a and find its harmonic conjugate, and hence f of z, यानी कि hence you have to find its analytic function f of z, यानी कि u plus iv. So ऐसी कोई वैल्यू आपको फाइंड करनी है so that the function will be harmonic. अभी हार्मोनिक के लिए क्या है वो आपको पता है. Here it's given harmonic, it means definitely you can write ux6 plus uyy equals to 0. ओके, सो ये वाला टर्म आपको यहाँ पे पहले से ही अप्लाई कर देना है, बिकॉज हार्मोनिक आपको पहले ही बोल दिया है. ठीक है, एंड इक्वल्स टू 0 अप्लाई करो, एंड डेफिनेटली यू कैन फाइंड द वैल्यूज ऑफ ए, एंड दिस वन इज कमिंग हियर 1. And then after the same procedure, analytic function as well as harmonic conjugate. So these examples you have to do, you have to solve with your own self guys. Now next, the last example is given. The question is find an analytic function f of z equals to u plus iv whose real part is u equals to minus r cube sine 3 theta. So you can observe guys, this one is again little bit different from the others, because here it's given polar form, right? It's not given into the Cartesian form. So method procedure आपकी same ही है, but यहाँ पे components है that will be changed here. Okay, so starting with the same procedure, that u equals to given, then you will find two components of r with respect to r and theta. तो यहाँ पे मैंने फाइंड किया है और उसकी CR इक्वेशंस आपको पता है. ठीक है, and then after I'm applying f dash z, यानी कि del u by del r plus I del v by del r, and here you have to apply its CR equations. So मैंने यहाँ पे उसका अप्लाई किया है, because see this one will be the case 1 only, because you can see the equation, in the equation it's given real parts, and real parts यानी कि the equation will be solved by using the first case only. Okay, so these equations we will write from the case 1 only. So here you have to change into the CR equations. Okay, now applying these both the values, and then after you have to apply this case r equals to z. वहाँ पे हम लोग कर रहे थे x की जगह पे z, और here we will apply in place of r z, and in place of theta we will apply 0. So putting the values you will get 3iz square, and then after 4th step you have to do the integration. So by integrating on both these sides with respect to z, you will get this term z cube by 3, and these 3 will be cancelled. So the remaining term will be f of z equals to I z cube plus c. So hope you all understanding very nicely guys, because this is a same example as we have practiced before the sessions. Okay, and today's session also. So I'm just giving main highlights of the example, and at the last you have to find its conjugate, and to find the conjugate you have to apply the values of z and f of z also. So f of z will be u plus iv, here I have written, and z अब तक हम लोग फाइंड अप्लाई कर रहे थे इन प्लेस ऑफ z x plus iv, but this one is given into the polar form, so definitely we will write r into the e raised to I theta. Okay, so in place of z now we will put e raised to r e raised to I sin I theta. So applying this and giving the simplification, and here you can observe that it will be e raised to I theta, but यहाँ पे theta नहीं है, 3 theta है. So in place of theta we will apply 3 theta. So this one will be cos 3 theta, यानी कि cis 3 theta, यानी कि cos 3 theta plus I sin 3 theta. And now separating the terms into the real and into the imaginary parts. So you will get as an conjugate v, because into the equation it's given u, यानी कि real parts is given into the equation. So as an harmonic conjugate, definitely you will find u. You will make a subject of imaginary parts, यानी कि v. So the v will be r cube cos 3 theta plus c. So I hope guys you all liked my today's session, and in this session one more examples I have given for the practice for your own self, and regarding any kind of queries you can contact me anytime. So in this session I'm going to complete the analytic part, and now it's just remaining one method, and after the completion of that method the unit 1 will be completed. Okay, so till that please do the practice of this all the sessions, this all the examples, because this, as I said before, this topic is very much important for the exams also. Okay guys, so please do more in one practice, and if you need more examples then also you can contact me anytime. Thank you guys. Now we will meet in our next session with the new method. Thank you.